In my previous two episodes, I explained how to make a quadcopter using the CC3D flight controller and the KK2.1.5 flight controller. I made a very fair comparison between the OpenPilot CC3D flight controller and the KK2.1.5 flight controller. While working on the CC3D flight controller, I faced many issues, and seriously, I wasn't really happy with the CC3D flight controller overall performance because it was very unpredictable. Sometimes the flight was so smooth, and then at the next moment the quadcopter would start twitching or falling out of sky. At this point, I realized that the CC3D flight controller is not good for the beginners at all, and since I'm making this series on different flight controllers just to help you guys which flight controller as a beginner you need to start with. So I decided to start with a KK2.1.5 flight controller, which is even cheaper than the CC3D flight controller. You don't need a computer software to set up this flight controller. You can change the PID settings at any time. You have the buttons and a display. Read the instructions and make changes as per your skills. With KK2.1.5 flight controller, I was very comfortable, and this is the reason I still recommend KK2.1.5 flight controller for the absolute beginners, because it's cheap and easy to set up. You can fly it in the aircraft mode or in the self-level mode. You can train yourself with this flight controller, and once you feel confident, then you can try some expensive flight controllers. Anyways, the KK2.1.5 flight controller really helped me in improving my piloting skills, and now I feel confident and I'm ready to try another flight controller. So today we will find out if we can beat the KK2.1.5 flight controller with the Naze32 Rev6 flight controller. Before I'm going to explain anything, first let's watch the Naze32 based quadcopter drone in action. This video is sponsored by Altium. Altium Designer is the world's most trusted PCB design system. Altium Designer enables engineers to effortlessly connect with every facet of the electronics design process. Over 35 years of innovation and development focused on a truly unified design environment makes it the most widely used PCB design solution. With Altium Designer, you can create PCB designs with an intuitive and powerful interface that connects you to every aspect of the electronics design process. Route it your way through any angle, tune for delay, push, slide, and walk around faster than ever. Interact and collaborate with mechanical designers like never before in a photorealistic 3D design environment. If you want to get started with the Altium Designer, you can click on the first link in the description. Just look at the stability of this quadcopter in the aircraft mode. Seriously, I wasn't expecting this level of smoothness. The control sticks were quite responsive, so I adjusted the RC rate values, and now I feel like I can fly this quadcopter. This is my first test, and of course I will further tune the PID values, as this quadcopter is for the beginners, so that's why I'm not using any branded stuff. I'm using simple 1400 kV brushless motors, fly sky transmitter and receiver, low cost 10-inch propellers, the same X500 Alien V2 frame, and the same 3S 3300 mAh LiPo battery. I really like the Naze32 Rev6, and I'm definitely going to make a racing FPV drone with it. So consider subscribing if you don't want to miss any of my upcoming videos, as this is my first video on the Naze32 Rev6. So in this episode I will only cover the extreme basics, including how to flash the firmware and how to set up the Naze32 Rev6 using Betaflight. Without any further delay, let's get started. The components and tools used in this video can be purchased from Amazon. The components purchase links are given in the description. This is the Naze32 Rev6 flight controller, which is based on the STM32 microcontroller. On the board you can see this arrow sign, which should be towards the front of the quadcopter drone. With these headers we connect our wireless receiver, which in my case is the FlySky FSI6. On the back side you can clearly see all the headers are clearly labeled. Next you can see we have these 3 rows of headers, and this is where we connect our brushless motors using ESC's electronic speed controllers. You can connect a maximum of 6 motors, as I'm making a quadcopter, so I will only connect 4 motors. On the back side all the headers are clearly labeled. The PWM, positive and ground. On the top row we will connect the signal wires of all the ESCs. Second row is for the 5V and third row is for the ground wires. The Naze32 Rev6 flight controller is also provided with these male and female headers. I will solder these male headers on the Naze32 board, and this will help me in easily connecting the wireless receiver and the 30 ampere ESCs. You can see I just soldered these male headers for the 30 ampere ESCs and for connecting the wireless receiver. Once you have soldered all the male headers, then the next step is to update the firmware on the Naze32 flight controller. Now at this point, like all other guys, you might have thought about using the Clean Flight configurator software. To be very frank, I also started with a Clean Flight and I was able to flash the firmware, but then it wasn't connecting. I spent hours on this, but it really didn't work for me, and there were so many other guys searching about the same thing. So at this point I decided to use the Betaflight configurator, and it worked for me in the first try, and this is what I'm going to explain right now. Connect the USB cable. Next you will need the flash loader demonstrator software and the Betaflight 3.2.5 Naze hex file. You can download these from our website electronicclinic.com. I will provide a link in the description. To flash the Betaflight 3.2.5 Naze hex file, first you will need to short these 2 boot pads, then plug in the USB cable and open the flash loader demonstrator software. Select the COM port and then click on the next button. If you can see the flash size, it means everything is fine, and click on the next button. Select device from the target list and click on the next button. Select download to device. Select the global erase and check the jump to the user program and verify after download boxes. Finally, you can select the hex file. Click on the next button and then wait for a few seconds. You can see the download operation finished successfully. Now you can close this software. First remove the USB cable and then disconnect the boot pads. Otherwise you will lose all the settings and you will have to repeat all the steps again. After flashing the firmware, when you connect the USB cable and you see this solid blue color, then it means the flight controller needs to be restarted. So to restart the flight controller, simply disconnect the USB cable and one more time short the boot pads and connect it with a laptop to run the flight controller. Once you see the green light start flashing, then you can disconnect the USB cable and you are all set. To further ensure if everything is done correctly, at this point you can open the Betaflight configurator. Connect the Naze32 Rev6 flight controller with the laptop. You can see it automatically detected and selected the correct communication port. Click on the connect button, and now if you can control this 3D model with the flight controller, then you're all set. Now the next step is to connect the FlySky FSI6 receiver with the Naze32 Rev6 flight controller. The FlySky receiver pins are clearly labeled. This receiver has a total of 6 channels which we are going to connect with the 6 channels of the Naze32 flight controller. Be very careful while connecting the wires. Connect channel number 1 of the Naze32 with the channel number 1 of the FlySky receiver. Similarly, channel 2 of the Naze32 with the channel 2 of the receiver, and so on up to channel number 6. Our FlySky FSI6 receiver connection with the Naze32 flight controller is done. Next, I'm going to replace the KK2.1.5 flight controller with the Naze32 Rev6 flight controller, and then next I will connect all the 4 ESCs with the 4 channels. Next, I'm going to secure the flight controller using the zip ties. I'm doing it temporarily. I will go with the same motors configuration. This is motor number 1, this is motor number 2, this is motor number 3, and this is motor number 4. The motor number 1 should be rotating in the clockwise direction, motor number 2 in the counterclockwise direction, motor number 3 in the clockwise direction, and finally motor number 4 in the counterclockwise direction. Before I open the Betaflight, I'm going to remove all the propellers. As you can see, I just removed all the 4 propellers and I'm good to go. Connect the USB cable and then open the Betaflight configurator. Click on the configuration and select the Quad X1234. Select the PWM. Turn on the motor stop button. Scroll down and on the receiver mode select PWM RX input 1 wire per channel. Everything else on this page looks good, and now I can click on the save and reboot button. Now go to the setup. You can see the roll value is a bit off. We will need to adjust this value. For this we will go back to the configuration. We can change this value. I'm going to start with 1 so that you can see how it adjusts the value. Now you can see the roll value is adjusted. Next, go to the receiver. Now you can start moving the control sticks. If any of the channel is opposite, then on the transmitter simply reverse that channel. I have already explained this in my previous episodes, so the transmitter is all set. Next, go to the modes. We will add the arm switch. When we press the button, it automatically selected the aux1. Next, I'm going to add the angle. I will use the aux2. Finally, click on the Save and Reboot button. Next, go to the motors, and all the propellers are already removed, so I'm going to click on the button I understand the risks. Slide the master button to its maximum value and connect the battery. After you hear some beeps, then slide the master button all the way down and wait for the final beeps. Now when you move the master button, all the 4 motors should start spinning. You can also check each motor individually to confirm the direction of rotation. If any motor is rotating in the wrong direction, then you can simply switch the red and black wires of that motor. Now go to the PID tuning. For now, I will go with the default values, but I will change the RC rate values. I'm doing this to make my control sticks less responsive. Next, on the receiver, set the RC deadband and yaw deadband values. I will talk about these in detail in my article. You can find link in the description. Anyways, don't forget to click on the save button after you have made any changes. Everything looks good. My setup is completed, and now I can click on the disconnect button. Once the setup is completed, you can remove the USB cable and start mounting the propellers. Next, fix the battery in place. Turn on the transmitter. Connect the battery. You can arm and disarm the drone using the switch. When not armed, the motors won't spin. This is for the safety. The motors will only spin when the Naze32 is armed. You can see the screen light. Now if you move the throttle stick, the motors will start spinning. So that's all for now. Support me on Patreon for more videos. I hope you liked today's episode. Like and share this video with your friends. See you in next episode, and thanks for watching.